In this section, we're going to take our Java Building 101 example, and instead of having to run all these different commands at the command lines with the locations of jars and classes, we're going to use a build tool called Gradle. Gradle, at its core, follows something known as convention over configuration. The idea is that you only want to have to declare something as a part of your build process that's different from an assumed standard. The standard in this case comes from the Java plugin. The Java plugin, once you apply it to a build, injects all these different tasks that have a certain order for building Java. You can see inside this diagram from the Gradle website, if you run build, for example, in the Java plugin, it first has to run some validation, which relies on running testing, which then relies on having to compile your test classes, which relies on having to compile your test Java classes, compiling all your classes, and otherwise just compiling Java. So it's a dependency chain of activities in which you can invoke any part within the chain to do something. This becomes very important later on if you're wanting to do things like run test in isolation. You can just say Gradle test and it will do just this part down the hierarchy. In order to execute, for example, the build task, I'm going to use the Gradle wrapper. So Gradle W, go ahead and do a clean to make sure I'm deleting anything that exists. Call the build task itself, and additionally I'm going to say -I, which gives me information about the build process to show what's happening. All that stuff means at the very end I get build successful, so it worked. So how do I validate that it worked? We know that it worked if we look at our project, specifically under our lib build directory, where we're going to see that we have a lib.jar, so the jar file that was built. But additionally, our unit testing now got put in a couple different places. We have some JUnit output here as XML, but under reports, we also have an index.html. If we look at that, we have a more human readable output of how our testing worked, down to the individual class level, class and method. That was a lot of output and functionality, so how did I go about doing this? To start with, I didn't hand assemble this project. If you have Gradle installed locally, you can actually run a command called Gradle init, which is an application creator. In this case, I ran it and selected a series of options. That I wanted to build a library, that I wanted it to be in Java, that I wanted to use the Gradle build inside the Groovy language, that I wanted to use Juniper JUnit, and also what to call it. And additionally, once I did that, I was actually able to then generate the wrapper. The wrapper is a way to run Gradle without already having Gradle installed. It's a preferred way to run Gradle because it doesn't depend on having anything else installed for you. By using this project generation, it establishes what the convention is. The convention in this case starts with a project, since it's a library, contains a lib directory. And the way this all ties together starts with the settings.gradle file. This is in the root project that gives it its name. This normally only matters when you're importing this into an integrated development environment. But then inside here, you want to include all the different directories that make up your project. In the case of the lib directory, it has its own build.gradle, and this is where all of the capabilities actually happen. You can see that it starts with applying the Java library. This is an existing core plugin within Gradle that when we apply it, it's what injects all of those Java-related tasks into the environment. Additionally, for dependency management, specifically how I pull all these different third-party jars from the internet, I have to declare where to get them from. In this case, I'm using Maven Central. In the next section, we have dependencies. There are 3 different types of dependencies in Gradle. We'll start with test implementation. Remember the test class path? This is what keeps the test classes separate from the other classes. So when we declare a dependency as a test implementation, it's only going to be needed to do essentially unit testing. The API dependencies are ones that are exported to consumers, so it ends up on their class path. For example, if you were to include this library, this is saying that in order for this to run, you're going to have it's going to also have to download this math3 from Apache Commons. The next type is the implementation dependency. This is something which is not exported to consumers. So if you were to include this jar, and this jar was dependent on Guava, the consumer of this jar would also have to declare the equivalent dependency. This is used to do things like not be specific to an individual runtime. It's a more advanced concept that I don't recommend using until you get more familiar with the build language. The other part is that we have to specify the type of unit testing runtime environment. And so this here is used to say any task associated with test, we're just going to use the JUnit platform.